Think math.
So far, every rule looked only at the number right before. What happens if it looks at the previous two together? Each next number is the sum of the two before it. Starting from 1 and 1, you get 1, 1, 2, 3, 5, 8, 13, 21. The Fibonacci sequence. What changes just because the rule looks at 2? What changes is how many seeds you need. A rule that looks back one place needs only the first number. But a rule that looks back 2 needs the first and the second before it can roll. With the same rule, seeds of 2 and 1 give 2, 1, 3, 4, 7, 11, a completely different sequence. How far back the rule reaches decides how many seeds it takes. Once the seeds are there, the rest is automatic. Why the previous two, though? The sequence came from a question about rabbits. This month's pairs are all the pairs that were alive last month, plus the pairs newly born. But only pairs that have been around since 2 months ago can have young. So this month is last month, plus 2 months ago. The previous two added. Now for the interesting part. Take the ratio of each pair of neighbors. 2 over 1 is 2. 3 over 2 is 1.5. 5 over 3 is about 1.67. 13 over 8 is 1.625. 21 over 13 is about 1.615. They swing above and below, closing in on one value. That value is about 1.618, the golden ratio. Why that value? We use last time's trick. Suppose the ratio closes in on some value x. Since each number is the previous two added, the ratio is 1 plus the reciprocal of the ratio before it. So x has to equal 1 plus 1 over x. Multiply both sides by x and you get x squared equals x plus 1. Solving gives 1 plus the square root of 5 over 2. That is 1.618. To sum up, a rule that looks at the previous two needs 2 seeds. 2 seeds and 1 rule settle the sequence completely. And the ratio of neighbors closes in on the golden ratio. We found that value the same way as last time, by asking what stays still. One question about counting rabbits reaches all the way to petals and pine cones. A sip of math every day, here at Think Math.